Right, the autorhythmic cells of the heart are basically 1% of the cardiac cells. And that 1% makes up the electrical conduction system. So the electrical conduction system consists of these little parts within the heart that create the action potential. So this first one, so this right here, this guy right here is called the SA node. SA node. And the SA node fires the action potential. Fires the action potential. And then spreads it through both atria. So SA node fires and it spreads through, just like it shows here, spreads through the atria, the right atria, and it also goes across and spreads into the left atria. Because the atria contract first, okay? So it spreads through the atria and then it funnels back to this guy. And that is called the AV node. So AV node, or atrioventricular node. So the AV node, once it gets the action potential, the AV node slows it down by pausing. It hesitates. So it holds it for, like a second or half a second or whatever, but it holds onto it, and it allows the atria to contract and to complete their contraction. So once the AV node sends the action potential, it holds on to it for just a second, and then it will send the action potential, and it sends it into the AV bundle. So the AV bundle is right here. So I guess we'll put that here, AV bundle. And as it's going down there, it is sending the action potential down here, and it is causing this little area to contract, and then it's going to fork into the bundle branches. So these are going to be the left and right bundle branches. And that action potential is going to continue to travel down the bundle branches, down the interventricular septum. And the muscles there in the interventricular septum are going to contract or start to contract. And it's going to send that action potential off those branches and all of that. So it goes down here, and then once it gets down to the base of the heart, or the apex, I guess is the better word for that. So right here at the apex, those bundle branches branch off into what are called the Purkinje fibers. go. Purkinje. So these fibers come up the walls of both ventricles. And they depolarize the contractile cells now in these walls of the heart, so the ventricular walls, and that causes the ventricles to contract. So the AV node after holding the action potential for a second, it sends the AP into the AV bundle. Then it runs down into the bundle branches, right and left, and then into the Purkinje fibers. And this causes the ventricles to contract. So atria contract first, obviously, through the SA node, and then that goes to the, once that's completed, it goes into the AV node. AV node waits to make sure it's completed, sends it into the AV bundle branches, and then down to the Purkinje fibers where the ventricles then contract. So this makes a lot of anatomical sense in the way that it's occurring, because these walls here don't contract until the action potential gets down to here. And then the action potential goes this way. So that means the contraction is starting here at the apex and then going up, which makes sense because the aorta, the aortic semilunar valve is there, the pulmonary semilunar valve is there, so it has to push the blood up to get it out. So if the action potential started up here, then it would, when the heart pumped, then it would be like pushing the blood into itself, like down to the bottom of the heart. So this way, it literally pumps in a way that it can pump up to those semilunar valves of the pulmonic trunk, the pulmonary trunk, and the aorta. The SA node. So the SA node fires the fastest. And it starts everything, okay? So it starts every heartbeat. It is the pacemaker of the heart. If left of its own devices, if without any other input to it, the heart rate would be about 90 beats per minute or so. But because of parasympathetic control, parasympathetic tone, it brings it down. And we'll talk about that in just a moment, or just in the next video anyway. The SA node, if something goes wrong with the SA node, then the AV node will take over. But the AV node, because it has the hesitating property and all that, it's slower. So it would make your heart rate really almost too slow. Sometimes the heart, for whatever reason, will make like little pacemakers in other places. Okay, so the heart can, this electrical stuff can start in other cells. When that happens, that can cause problems as well. When if someone has a pacemaker, that's what is acting as the SA node. if someone has a pacemaker. It means that their SA node isn't working or whatever. And that pacemaker that they put in there takes over and is able to regulate the heart rate.